Welcome back. In previous session, we have completed the LED interfacing with Arduino and its simulation using Proteus. And today we are going to see about LCD interfacing with Arduino and its simulation. Generally, the LCDs are used for displaying the data or character while doing the projects and some applications. So first we start with LCD pinouts and its signals. We are going to see about 16x2 LCD. What is 16x2 means? There is 16 columns and 2 rows. So now we are going to see about the signals. What are the pins used here? So first one is here VSS. VSS are ground. Second one is VCC. We are going to give plus 5 volt DC. And third one is VEE, that is LCD contrast pin. Here we have to give the voltage in between 0 to 5 volt. So if you are giving 0 means the total LCD will be blank. If you are giving 5 volt means the LCD will be full black. So we are going to give in between 0 to 5 volt. It will be done by the variable resistance called as part. Then the LCD control signals. The first control signal is RS. The first control signal is the fourth pin, RS, register select. So inside the LCDs there are two registers. One is data register and another one is control registers. So what kind of registers we are going to access is given by RS or register select. Then the fifth pin is R bar W, read bar W. So this pin should be 1 while read the instruction or data from the LCD. And this pin is going to be 0 while write the data from a microcontroller. So we are always write a data to the microcontroller, so it is always held at 0. Then the third signal is enable. To enable the data register or display register, we are going to give the control signal as enable. So these RS enable and R bar W control signals are used for connecting LCD with the microcontroller. Then D0 to D7 is the data lines, digital input lines, which is from microcontroller to display the record, character or data in the LCDs. So we can configure this LCD as 4-bit or 8-bit one. So we can use D0 to D7 or we can use D7 to D4 as 4-bit mode. So we can see it later. So this is the pin configuration of LCD. Next we are going to see about the programming part. So in this programming part, the first line is include liquid crystal dot h. We are adding the library. This library will manage all the control signals that are required to the LCDs. So just we need to assign the pin numbers that to be connected to the LCD. So here liquid crystal LCD 12, 11, 4, 5, 6, 7. So these are all the pin numbers which are going to connect with the microcontroller. So 12 is RS, 11 is enable, 4, 5, 6, 7 is D4, D5, D6, D7 as 4-bit data mode. So here note that the program is case sensitive one, that is L and C will be caps, the remaining will be in small. So then inside the void setup, LCD dot begin 16, 2. We are going to connect a 16x2 LCD, 16 column and 2 rows. So we are configured as 16, 2. Then inside the while loop, set cursor LCD dot set cursor 0, 0. So we are going to write the PCB designing the data into 0th column and 0th row. That is, it is 0th row and 0th column. So next set cursor 0, 1. The next data should be write at 0th column and first row. So that is 0th column and first row. So here itself the programming part is over. Next we are going to the connections part. So we are already given liquid crystal dot LCD 12, 11, 4, 5, 6, 7. So 12 we are going to connect RS, 11 we are going to connect enable. So 12 is connected to here RS and 11 is connected to pin number 11 is connected to enable, and then the R bar W should be connected to ground. So always we are going to write the data to the LCD. So this R bar W should be connected to ground. Then there is 3 power signals. VSS is connected to ground. Then VDD is connected to plus VCC, that is plus 5 volt. The third one is VE connected to the middle of the part, variable resistance. So that the input to the VE should be between 0 to 5 volt to make the optimum brightness or contrast in the LCD. So here is the connection part. Next we have to go for Arduino programming. So just copy this code or type, open the Arduino IDE, delete the existing, here paste the code. Now we are going to compile. So before compiling, ensure that in preferences all the checkboxes are enabled except use external editor. So press OK. So this is compile button. This compile button want to save in desktop, type LCD, save. So compile button compiles for error and generates hexadecimal files. Machine language format it converts. Sir, here we are going to see where is our hexadecimal file. So there it is the location. Note that the extension should be .hex. It's an important one. So I am going to copy this and go to the Proteus Software. Directly open the schematic capture. I'm going to take component mode, pick components, keyword Arduino. Going to rotate plus key. Then I want LCD 16 cross 2 LCD. Here's 16 cross 2 alpha numeric LCD. Select this, rotate plus key. Now I need supplies VCC, ground and variable resistance. I need VCC, ground and one variable resistance. This variable resistance is called as part. So in pick component, type POT part. So in resistance variable, select part has G. So select part has G. Select this. I'm going to rotate plus key. Then I need ground and VCC. So here on terminal mode, here terminal mode, press this. Here there is ground, press here. I want to rotate ground. and for VCC, here there is a power. Select the power, rotate, go to selection mode, double click the power, and inside the string you have to make it as VCC. It's important one. Also ground, in string make it as ground. Okay. In part, one side is VCC, another side is ground. Then the output is connected to contrast pin VEE. Then VSS is connected to ground. VDD is plus 5 volt. The power part is over. Next, I am going to connect the control lines. RS. From our program, RS is number 12. Pin number 12 is connected to RS. Then pin number 11 is enable. Then R bar W, you are always writing the data to the LCD. I am going to connect with the ground. So control signal is also over. The data lines D7 7, D6 6, D4 4, D5 5, D4 4. Here 7 is D7, 6 is and 5 is connected to is connected to D4. So the connection part is over. Next we are going to make the program inside the Arduino. So for that, here there is a path, hexadecimal path, C:users lcd.ino.h, press Ctrl C for copy, and open, double click the Proteus, here in program file, press Ctrl V, and OK. Now run the simulation. And the simulation running, the PCB designing welcomes all. So it is our data in the program. So PCB designing is 0th column, 0th row, and welcomes all 0th column and first row it is displaying. So from this we have completed the LCD interfacing with Arduino and its simulation. In tomorrow's session we are going to see about DC motor interfacing with Arduino and its simulation. Thank you.